And I'm clicking admit all now, guys, just so you know, people coming in. So good evening, everyone, and welcome to the Falconer Natural History Lectures from the University at Albany's Atmospheric Sciences Research Center. It's nice to see everyone. We hope everyone is having a wonderful summer. My name is Mark Boharnwa. I am your meeting host this evening. I will review our Zoom protocols, introduce tonight's lecture host, and will moderate the post-lecture question and answer period. Tonight's presentation is Overview of the New York State Mesonet, Regional Weather Patterns and Phenomenon Uncovered. This is the first of 4 Falconer Lectures in our summer 2021 series. Before we get started, let's review our Zoom protocols. This lecture, all messages sent to the Zoom chat feature and the post-lecture Q&A are being recorded. And all participant video and audio has been disabled until the post-lecture Q&A period. You may submit any comments or questions to the chat feature at any time. However, we will not be addressing those until the post-lecture Q&A session. Please do not use the Zoom raise your hand feature until the post-lecture Q&A period. Any raised hands will be addressed in the order they were received, and you will be asked to unmute to pose your question. You may also at that time enable your video if you so choose, but please remember, if you're going to ask a question, to make sure your background noise is at a minimum. Before introducing tonight's lecture hosts, I'm going to now play a brief video from ASRC's director, Dr. Christopher Thorncroft, providing a history of the Falconer series and a bit about ASRC.
Before we come to the speaker today, I wanted to say a little bit about the Ray Falconer, whose name is given to the seminar series. So in 1961, Vince Schaefer founded the Atmospheric Sciences Research Center and shortly hired thereafter Ray Falconer as ASRC's very first full-time employee. Ray was often referred to as Mr. Weather. From his early days as a weather observer atop Mount Washington in New Hampshire to his work at the General Electric Research Laboratory in Nobel laureate Irving Langmuir's Project Cirrus, Ray was an enthusiastic disciple of the atmosphere. Ray's boundless energy was poured into public education on weather and the environment. His popular radio weather commentaries, his articles, and his lecture series made him widely known as the voice of the ASRC. Ray initiated this lecture series in the summer of '62 at Whiteface Mountain. And in 1973, ASRC expanded the series to include a spring version on the Albany campus, which is this present series. This series is deeply rooted in ASRC's history and offers scientists a unique opportunity to engage with the general public. Indeed, we have a fantastic slate of strong interdisciplinary talks this year. And I would like to thank Dr. Craig Ferguson and his committee for doing such a great job in creating such a strong slate. Before going on to introducing tonight's speaker, I wanted to say a few things about the center for those of you who may be less familiar with what's going on these days. I just want to highlight a few of the areas that we do that are important for the society and the state and the globe. We work on air quality and atmospheric chemistry, observations theory, including many observations that take place at our Whiteface Mountain facility. We do a lot of work on boundary layer meteorology, which is basically looking at the atmosphere close to the surface and how energy, temperature, and moisture are transmitted between the land and the lowest levels of the atmosphere. We also have a growing area in applications of artificial intelligence and machine learning. We've recently deployed some quite strong computing infrastructure to support machine learning through the Excite laboratory, and are contributing to a national institute, a $30 million institute in artificial intelligence and trustworthiness. We do lots of work in climate and weather, including extremes, and we also are very strong in renewable energy, wind and solar, to name but a few. Finally, just want to say that we're very excited about this summer. We are going to be moving into a new building, the so-called ETEC Building, this summer. And in this building, along with ASRC, we will be joined by the Department of Atmospheric Environmental Sciences, the New York State Mesonet, a Center of Excellence, the Excite Lab, as well as our local National Weather Service Forecast Office. A dream come true for bringing all of these entities together. And we will also be co-located with the new College of Emergency Preparedness, Homeland Security, and Cybersecurity, as well as environmental engineering. A huge opportunity to promote and continue interdisciplinary research.
Okay. So before I introduce tonight's lecture hosts, I just want to remind everyone, you should have received an email reminder for the summer series with a link to a survey asking for your feedback on the series, any changes you might like to see, recommendations you have, and also very importantly, if you have any speakers in mind for future Falconer lectures. So Dr. Ferguson has put the link to that survey in the chat. So we ask that you please take a couple of minutes and provide your feedback. It would be very helpful to us. Tonight's lecture host is Mr. Paul Casson, Operations Manager at the Atmospheric Sciences Research Center's Whiteface Mountain Field Station. Paul will now introduce tonight's guest speaker. Paul?
Thank you, Mark. Ever since Scott was little and realized knowing something about the weather would benefit him, given all the time he spent outdoors backpacking, paddling, and skiing, he's been a weather enthusiast. Scott has degrees in meteorology, math, and physics, and advanced degrees in hydrology and education. Scott has worked for the National Weather Service as a teacher in both K-12 and university settings, and currently works as a research support specialist for the New York State Mesonet. When not actively enjoying the many moods of the weather, Scott can be found enjoying his family at home in Gabriels, New York. Without further ado, we'd like to start tonight's program. Take it away, Scott.
Great, Paul. Thanks very much. And thanks, Craig and Mark, for organizing all this. It's great to be part of. Let me share my screen here. Great to be part of this. And as not only a speaker, but as a local and someone who enjoys local science and the sharing of it, this is a tremendous resource. So thank you all for your hard work in making this happen, even if it is still over Zoom. We're making it happen. Okay, I think I see some thumbs up here. Hopefully
we can see it.
Okay, thank you. So for tonight's talk, I'm going to speak from the perspective of as my role as lead field technician for this newish Mesonet, which is a network of weather stations around the state of New York. I'm basically going to give a tour of New York weather through the lens of this Mesonet. We're pretty young to talk about climate and things like that, but we do have some interesting things to share. And I'd like to share a little bit of what we do in the Mesonet. So tonight I plan to go over a brief on a kind of a primer on New York State weather, talk a little bit about what we do with the Mesonet, and then some emerging takeaways, some things that we have found weather phenomenon-wise from the data from our weather network, and then some future directions and some opportunities for future research. So if anyone's a weather buff, which I guess if you're part of this series listening in, chances are you are. You get talking to other weather buffs, and pretty much the conversation always leads back to everyone trying to prove how their location has the most extreme or the most changeable or the most interesting weather. So my talk tonight, I guess, is a bid for how New York often has some very, very interesting weather. And that all has to do with geography. So I want to kind of set the scene here. I'm a maps person. Many people into weather are also map people. So the geography is kind of what sets the scene here. New York is a very varied place spatially. We have the Great Lakes on the western side, which induce influences in both summer and winter, moderating effect in winter before the ice freezes over, and a cooling effect largely near shore in the summer. You have coastal areas, Long Island, Hudson Valley, that gets affected by air masses off the Atlantic, especially northern part of the state, but the whole part of the state gets affected by air masses coming down from Canada, especially in winter. Our proximity on the east side of the continent gives us, we are a crossroads for storm tracks coming from the west, from the north, from the south. And we'll talk a little bit more about that as far as summer weather is concerned later in the talk. So a lot of different varied weather. Some images I grabbed from some media outlets on the bottom left here shows Isaias, the storm track on the bottom left. So we see tropical systems, as we all know, and they wreak havoc as they turn extratropical up by us, often in the form of inundating rains and flooding, not so much wind events. And then, of course, we're all familiar with the wonderful, personally anyway, winter weather that we get. So kind of drawing on this geographic bent and it affecting the weather so much, because of this mixed bag of geography we have, we get a phenomenal array of different weather phenomenon. And again, this is my bid for saying how New York weather is very, it can be very extreme, very changeable, very exciting, and perhaps more than most other locations. We have one of the world's best setups for lake effect snow. That's the LES. Aside from the Sea of Japan and the northern island of Japan, it's probably the world's best setup for at least small scale lake effect snow. We'll talk about that. Image in the bottom left shows a winter season accumulating snowfall there, a downwind of Lake Erie and Lake Ontario. We get nor'easters off the coast. As I mentioned, we are kind of a crossroads of a bunch of different storm tracks, different seasons. We have blizzards, extratropical systems, deep winter cold, summer heat and humidity, which we've been dealing with this summer, and then all sorts of convection and severe weather, thunderstorms, derechos, flash floods, and tornadoes. So this is a great place to be interested in weather. One of the things that keeps me engaged is it's very changeable and every day is something different. Locally here, we have a pretty long memory of how weather does affect us. This is a photo just upstream from All Sable Forks, which is just down the hill from us here at the Whiteface Field Station. So 2011 Tropical Storm Irene came up the coast and then transitioned to an extratropical system, morphing with a system coming across the Great Lakes, tremendous amount of rain. As you can see, this homeowner, it's a business, spray painted the water line from Irene. On the far right, you can see the river. This was actually earlier today. That's the All Sable River East Branch, I believe. So you can see the height difference, at least 15, 20 feet that river came up. On the bottom, there's a blue line on that concrete. That was actually a high water line from a end of April flooding event that same year, 2011. Upper left is a hydrograph showing how high the Hudson River got a little bit to our south with that event. So we're going to kind of transition into the Mesonet, which is where I work and I oversee the field operations for the New York State Mesonet. So kind of breaking down this word Mesonet, meso refers to, it's a scale feature both in time and space, not micro, not macro. We can capture things much less than a synoptic scale, but a little coarser than the micro scale. So a lot of sub-phenomenon that we couldn't capture in the state with the 27 different ASOS and AWOS sites before the Mesonet was deployed, we can now capture because we have basically a much tighter mesh of weather stations around the state to capture these phenomenon. We are a full end-to-end system. We collect the data, we process the data, quality assurance, quality control, and then we push it out to users. For the general public, it's available on our website. And we also have a Twitter feed. I'll go into those in a minute. The observations is very important as far as it being a key ingredient for the numerical weather prediction system. All models need to be initialized with initial conditions. So all of the data we process gets pushed out to the Weather Service and the MEDIS system, and it does get initialized into model states. models being numerical weather algorithms, which forecasters use to help predict weather. So we are part of that system. And aside from numerical weather prediction, emergency management community uses our data, aviation, commerce, and then a lot of people just on the ground in New York, farmers, travelers use the data as well. Here's some links, and I'll have these at the end on how to access our data. This is a screenshot of our website showing all of the blue dots on the right are weather stations, excuse me, across the state, and then a whole bunch of data associated with each of those. I'm going to grab a drink of water here. So why a Mesonet? We are just over 5 years old, almost 6 years old now since our first site got installed. And it really is a situation of up until 2012, we had repeated high impact weather events. Working in sequential order, ice storms, then we had quite a bit of flooding, and then the three kicker storms were Irene, Lee, and Sandy that affected huge parts of the state, especially the mountainous areas of the Catskills and Adirondacks. So it was deemed, question was asked, we have very little data. How do we kind of fill in some of these gaps so we know what's happening? A lot of the driving, all the driving mechanisms for these flooding events are antecedent soil moisture conditions and then input of rain. And we were largely blind to what those initial conditions were. So the Mesonet is an effort to kind of fill in those gaps. The map on the bottom right there shows the existing before we came online, 27 official FAA ASOS sites around the state. So this is a slide kind of justifying our existence from an economic standpoint. Gross state product, New York is one of 6 states that has the highest sensitivity to weather phenomenon. So weather affects all of us every day, but as far as affecting the huge economy here in New York State, with New York City being probably the biggest driver, New York remains very vulnerable to high impact weather events. So this was also another huge driver in the creation of the Mesonet. So this is a map of all of the weather stations across the state. Basically, it's every 19 or every 20 miles across the state. One of these, I would call it, although I guess I'm biased, high-end weather stations that has a whole host of different data, and we have a bunch of different networks. All these green dots are standard sites, which measure kind of standard meteorological parameters such as temperature, wind, pressure, soil, precipitation, those kind of things. We also have a snow network at 20 sites, mainly clustered in the Adirondacks, the Catskills, and a few in the lake effect areas that measure SWE, snow water equivalent, which is if you were to melt down the snowpack, how much water is in that snowpack. We also have snow depth sensors at those locations. We have profiler networks, which take vertical profiles of the atmosphere to measure temperature, wind, and moisture in the vertical, pointing up to 6 kilometers in the atmosphere. And then we have a smaller flux network, which are the orange red dots, I suppose, which measure sensible energy balances coming from the ground to the atmosphere interface. So all of the data we collect is run through the Verizon network, and then it all gets piped to Albany instantaneously. We run it through a whole bunch of algorithms that QA/QCs the data. It is archived, and it's also pushed out to all of our users, including the public, with the main interface for the public being the website. This is kind of a schematic of a standard site. It is research quality, and we have very strict calibration protocols on all of these sensors. Not at all downplaying home weather stations that might be in people's yards or on their roof. Those are very useful and have their own purposes. But this data is very stringent, adheres to protocols for calibration and all against national standards, temperatures. We have a regular schedule of rotating out sensors, either calibrating them in the field or back in the lab. So the idea is it's very high quality data with which research can be done off of it, and also real-time decisions can be made if we're in the midst of some type of high impact weather event. So temperature, wind speed, wind direction at 10 meters at the top of the towers. We have surface pressure, dew point at 2 meters. Our rain gauges are weighing buckets, so we actually collect everything on a load cell and weigh it, and then based on the density of water and that weight, we can back out how much rain or frozen precipitation has fallen. We also have soil moisture and soil temperature probes buried in the ground at each one of these locations. Those are some of our favorite weather variables for the farmers. A lot of these sites are located on private land, on farms. There are many of these located on public land, SUNY campuses around the state or state parks. But the ag community takes a lot of stock in the soil data that we provide. We also have a camera network. Every one of our sites has a webcam that is accessible to the public as well, and that we use for a lot of phenology, date of last snow melt at a site, or bud out or leaf out at sites. We see all sorts of interesting things on these cameras. So this is what one of these sites looks like in person. This is our Red Hook site in the Hudson Valley, south of Albany. All of these sites for scientific purposes will look exactly the same. They're 10 meter by 10 meter fences on each side with a 10-meter tower. And then for comparability reasons and repeatability, temperature sensors are located at the exact height of each of these sites, 126 of these around the state. So from a technician's point of view, servicing these, everything's very predictable. We know where everything is, which is a good thing. So by the numbers, I'm kind of a numbers guy. I guess people who are into weather tend to be numbers people. So we've collected over 1 million observations so far. All of those have been quality controlled, processed, and archived. As I said, we have 126 sites. We have close to, well, that number is probably closer to 15 million at this point in hardware assets deployed across the state. Many of those are on rooftops in New York City, but the rest are these weather stations around the state. Over 4,000 sensors currently deployed in the network. Myself and currently 2 other technicians are in charge of maintaining the whole network out in the field. Anything that comes up at a site that has to get visited, that's on us. Then we have a whole team of people back in the office who do all the computer end of things, processing of the data, and also working with the public. Our highest elevation is Hartsville, down in the southern tier, just over 2,400 feet. Our lowest elevation site is Southold, out on the east end of Long Island near Montauk. We have 17 sites within the blue line of the Adirondack Park. Our Wantagh site is closest to the Atlantic, just over 2 miles. Our Chazy site, extreme northeast corner, just over 2 miles from the Canadian border. Our Cape Vincent site, which is at a winery, is just about a half mile from Lake Ontario. And the largest straight line distance from 2 of our sites, we forget how big our state is, at least for Eastern standards, is just under 400 miles, which is a lot of driving. So one of the magic things about a mesonet is it allows us to see kind of sub-synoptic scale or sub-macro scale phenomenon with great resolution. This is a great example of a screenshot from last January, kind of a pretty wonky temperature pattern across the state, kind of a warm thumb or nose going up into the central Adirondacks, cold air kind of damming, creeping down south in the Champlain Valley. Then you see 2 values pretty close to each other there. Our, I believe that's Whitehall, and our Glens Falls site there, excuse me, sorry, 60-degree temperature right next to a 35-degree temperature. So pretty strong boundary. Without this fine mesh of weather stations, we would have missed that, and that's a pretty unique thing. So talking about this is similar pattern from a very different, from over a year later. So why the strange temperature regime? And this is something that a mesonet can help you kind of pluck out here. This doesn't look like a normal front, a normal boundary of any type. But when you overlay our radar, which our computer scientist does very well for our website, you can see that that's all cloud cover and much, much cooler with rain falling, whereas the rest of the state is clear and getting incoming solar radiation and thus warmth. It's a great example of a cold front. Earlier this year in April, we were up in the mid to lower 40s up in the Adirondacks, and then the city was still in the mid 70s with a pretty sharp boundary going kind of southwest and northeast across the Catskills. Very interesting. So down in the city, you have 93 degrees, New York City. I believe that's our Staten Island site. We're up near the Canadian border at our Malone site. We're 58 degrees. So we're a pretty small state here, but this is just this timestamp alone, almost a 40-degree spread, which is pretty phenomenal. But can we do better? So we are a mesonet. Again, I want to stress mesoscale. There are micronets, and I want to point that out. This was from last month, a little band of showers between our Gabriel site, which is that 4 wind speed, and our Malone site, which is 14 for wind speed. And there's a little patch of showers moving through that all of our rain gauges missed. So while we fill in the state quite well, there is certainly room for more weather stations and more spotters or eyes on the ground, so to speak, capturing what we can't see. Of course, we have remote sensing and radars, which we can back out precipitation, but ground truthing those remote sensing instruments is pretty important. So as I mentioned, we have we're the first mesonet that has a camera network, and maybe I should talk about the first mesonet. Oklahoma has a very high-end mesonet that's designed with the motivation of warning time for convection, mainly tornadoes. There are many other states with mesonets. We're the first one with a camera network. On the public page, every 5 minutes, you can see the camera update, but we've captured all sorts of things from animals to 6-foot-high fences being buried in snow to deep convection, some water spouts, cicadas in the middle left photo there, rainbows, fireworks, bottom center from our Staten Island site over New York City, some beautiful sunrises. In our operations center at the University of Albany, where we're housed, we have monitors that show all 126 of these cameras. And the Weather Service also monitors our cameras for forecasting and kind of situational awareness reasons very often. So this is our Cincinnati site. Again, every 5 minutes, it just takes a quick image. And this one happened to catch a bird eating something kind of right in front of the camera. So certainly some bizarre things, which we like to highlight. We do have an educational arm. We are a science organization and connected to University of Albany. So we believe in sharing this rich pool of data that we do have. Fits nicely in with STEM initiatives. So through a lot of different initiatives within our organization, we team with local schools, give tours of sites, and even have developed some curriculum for public K-12 teachers to use across disciplines, science and math. So there are certain challenges maintaining a statewide network, and with our strict protocols of grass height can't be over certain heights, swapping out sensors, we need to visit the sites quite often. I just wanted to throw in a couple slides of some of the on-the-ground challenges. So stinging insects, and it's pretty interesting. We compare notes that technicians, we're in charge, each of us, about 40 sites around the state, and we compare notes. And pretty early on in the season, we can tell, is it going to be a bad year for stinging insects, or is it going to be a bad year for mice building nests? Happily, I can report this year, we don't have as many stinging insects building nests, which is a good thing. So we have mice there building a nest on the left underneath the hood of our rain enclosure. That enclosure houses our data logger and our modem, kind of all the guts that runs the whole system at the base of the tower. Some robin eggs in a tipping rain gauge, top right there, and then a lot of mice, and mice like to chew wires and often create a mess. As humanely as possible, we like to eradicate them and encourage them to find homes elsewhere. Some other kind of hardships associated with the job that most of us find fascinating, just part of the job. Upper left there, if you can read that digital sign about to cross the George Washington Bridge on Route 80, says 62 minutes to travel 4 miles. As much as possible, we try not to travel to our sites in known areas of traffic during busy times. So we're often up early, up late, just to get to sites and be a little bit more efficient. Upper right is the Black River. Oftentimes we find weather-related phenomenon that not so much traffic or human-based that inhibit us getting to sites. Bottom left is our Redfield site in the southern Tug Hill, which is kind of the bullseye for lake effect snows. You can see the enclosure on the bottom right there. You actually cannot see it. It's covered with this big cap of snow. And then this was a little frog that's in one of our data enclosures. We're kind of stumped how he got in there, but he was alive and well, and we freed him. On the left there is, we have a subnetwork in New York City, a micronet that's involved with a utility. So that's me putting in a water temperature sensor in a stilling well in the Hudson River. Very interesting part of the job. Upper right is a snow scale. If you can see, the scale is reading 10 inches of water. That's quite a bit of SWE in a snowpack. And that was on the Tug Hill at our Osceola site. And then the bottom right is on top of Manhattan, where we have our fixed towers, one in each of the 5 boroughs in New York City, climbing towers in the city, which is a fun, unique part of the job. Other challenges on the upper left here, that's a pyranometer, measures incoming solar radiation. Obviously, when it's covered with snow, it's not doing a very good job at measuring incoming solar radiation. So part of the task of our QA, quality assurance, quality control team, is to flag out data that is not correct, that we don't want to push out to different users, which is a huge task in and of itself. Most of it is automated at this point, but it's always nice to have eyes on the ground, and they appreciate photos of things like this, why that sensor is reading such low incoming solar radiation. Bottom right is our Old Forge snow site, a SWE sensor hanging in between the 2 tripods there with a snow depth sensor. And then I've dug a snow pit in the foreground, doing a profile of temperature and SWE cores to verify the passive sensor that's also measuring SWE. You can see on the right side, our standard site there. So I wanted to, let me get a drink of water here. I wanted to go into some interesting findings that we've found with the Mesonet and share some records. I want to kind of front load. We are a very new network. Generally in the weather and climate world, you don't start talking about climate normals and expected weather climatology until you have about 30 years worth of data. So we have 5 going on 6 years at our longest sites. So certainly not going to talk about any normals or kind of aberrations because we have not established what normals are, at least for our sites. But wanted to go over a couple interesting findings and some conversations we're having with the scientific community about our findings. So as many people know, Saranac Lake is often considered one of the cold spots of the country. International Falls, Minnesota being another one, I should say lower 48, not including Alaska. But there are many mornings in the winter where Saranac Lake is the cold spot in the lower 48. It's called Saranac Lake. It's actually in Lake Clear as the temperature sensor at the airport there. A lot of people have often questioned why that is so cold. I'm going to go into a couple slides, not necessarily being the end all, giving you a reason why, but perhaps exploring some reasons. So the graph here is a graph of Gabriel's, which is our site about 0.9 miles as a crow flies northeast. I'll show you a map in a moment of the automated surface observing site at the Lake Clear Airport. So the black dots are nighttime temperatures. The red X's are daytime temperatures. With the blue line showing the difference between the two at night being the best fit curve. So you can see temperatures kind of straddle 0, the difference between the two during daytime hours. And there is quite a bit of a difference at nighttime. And a lot of people have asked why this is. A lot of people have questioned the sensor at the ASOS at the Lake Clear Airport. So kind of give you an overview here. In the upper right, GABR is where our New York State Mesonet site is. It's in the middle of a potato field, Tucker's farm there in Gabriel's. And then bottom left, I show you the runway there at KSLK where the ASOS is. So those are the 2 locations, is about 0.9 miles apart, about 100-foot difference, with the ASOS being a little bit colder, a little bit lower. So this is another kind of visualization of that. You can see during the shaded times, and those are the night times, where you can really see the temperature difference between our site and their site. And then why is that is the question. So this has been written about in various media outlets locally up here, the Adirondack Explorer, Adirondack Daily Enterprise. Is it real? is an artifact of the thermometer at the Lake Clear Airport. We consider all data bad until otherwise proven correct, but the weather sensor, temperature sensor at the ASOS is not a Mesonet one, and I have no reason to question it. It does sit in a kind of a high mountain valley. It's about 100 feet higher than the village of Saranac Lake, so it is a little bit higher, radiates out. Cold air from the surrounding area drains to it. And another part is very sandy soil, so there's no moisture to actually hold in heat during the cooling hours, especially during optimal radiational cooling nights and mornings where you have calm winds, clear skies, and long wave radiation is allowed to escape out. So an ongoing investigation locally, but it is nice to have our Mesonet site so closely co-located to the official airport sensor there for comparison purposes. So I want to quickly go through some records. Again, we've only had 6 years, but and then so maybe some questions. Why is this the case? So these are 5-meter soil temperature records. So this is showing the minimum temperature ever reached at our 5-centimeter level at all of our sites, and the number reflects that value at the location there. And according to farmers, this is very interesting, and depending on the how dogmatic some of the farmers are, even incorrect. We've taken these sensors back to the lab and tested them. The farmers expected the temperatures to get much, much colder, even just at 5 centimeters, even with a snowpack, which we know can insulate temperatures throughout the winter. But what we have found, and this needs a little bit more investigation, but wet soils that tend to hold on to moisture in the soil matrix, seem to asymptote or kind of approach freezing, but never get much below freezing. And that seems to be a surprise amongst many people. I'm not a soil scientist, but many of the farmers have been very surprised at that finding. Temperature seems to get stuck around freezing, especially if there's much moisture in the soil there. Interesting thing about record maximum temperature for the network is actually one of our most northern sites. It's way up at the top there, our Louisville site. That's just about 2.5 miles from the St. Lawrence River. But this is still current. I just checked it this afternoon, even with the heat we've had the last 2 or 3 weeks, but not counting heat index, the highest maximum temperature we've had is one of our northernmost sites. And then when you compare that to our record minimum, a record low temperature site, it's in the same neck of the woods. So -39 at our Philadelphia site, which it's just north of just north of Watertown there. So the same area of the state currently for the last 6 years has the hottest and the lowest temperature, which going back to the conversation I mentioned early on about people liking comparing where they live and saying how their weather is the most extreme, interesting, changeable. I think the St. Lawrence area up there certainly has something to prove. The official state lowest low temperature is -52 at Old Forge, and Stillwater Reservoir also tied that in 1934. We've always known the Adirondacks to be a cold spot. But during optimal radiational cooling nights in the winter, we are finding this area just north of Watertown. And this image shows it pretty well, that -20 radiates out in a very, very surprising way. I think we knew this area was cold, but perhaps not as cold as we have found. It is a very safe bet for very clear skies, calm winds, and a snowpack for that Philadelphia site, or Edwards just to the northeast of it, to be the coldest spot by the morning. Radiates out very, very well. We think it's north enough not to be moderated by the proximity for Lake Ontario as one of the reasons it gets cold. Another thought is perhaps a Catabatic wind flow, which you can have a cold dome of air on top of the Tug Hill, which is at a higher elevation. And then because of density sliding off to the northeast, right into that cold valley of the St. Lawrence there, where the Lake Ontario empties into the St. Lawrence. You can see from this data in the upper right there that there's a very subtle 0 to 2 mile per hour wind out of the southeast, which is the direction of the Tug Hill. And the thought being that very cold air could slide off that dome, the Tug Hill plateau, to that site. So I also talked about changeable weather. So the maximum 24-hour temperature change at any one site is also up in the same area. The same site that has the -40-degree temperature record for our network has also seen a 60-degree temperature swing. So this interesting area, and perhaps I'm biased being based out of our Whiteface office for the North Country, but statewide, some very impressive 24-hour temperature changes. And that really speaks to how we are in the crossroads of this battle between oftentimes cold Canadian air coming from the north and more humid, warm air masses coming from the south, and them doing battle right over us. Some days the cold air winning, some days the warm air winning, and some days both of them winning, depending on where you are in the state. So what was I getting at here? 24-hour temperature. So I wanted to point out in a single day, the temperature spread here. So Manhattan being 80 degrees, the highest temperature for the last 24 hours, and the coldest being Wilmington, which where I am at Whiteface, the town being Wilmington. 40+ degree swing in a single day. And this is just a day I happened to grab a screenshot. So we are a small state by Western regards, but Eastern, we're a state with varied land and very varied weather, depending on the day. One of my backgrounds is in snow, so I wanted to put a couple things in here about snow. Maximum average daily snow depth. So this shows you kind of where the Catskills are, kind of where the Adirondacks are, and certainly the lake effect areas. Our Redfield site, maximum 24-hour snow depth average was 43 in any single day. So that's approaching 4 feet of snow on the ground for a whole day, which is quite a bit. I'll give you a second to kind of digest some of these numbers. You can see the Catskills showing up. And then the surprising cluster, perhaps in the Hudson Valley, all coastal storms and nor'easters, adding prodigious amounts of the wonderful white stuff to the Hudson Valley.
Hey, Scott, about 5 minutes if you can.
It sounds great. Yep. Thank you. Yeah. So this is a lake effect event from our Redfield site. A little video here showing a huge dump of snow. That's a 6-foot-high fence that ends up getting buried. Again, this is from the webcam at our Redfield site. So we can do all sorts of neat stuff with these camera images. This is what happens to a rain gauge when it snows so quickly. So the data we did not capture as far as the water equivalent in our rain gauge very well. This is a phenomenon called sastrugi, which is basically snow dunes, kind of like sand dunes. But the wind pushing snow dunes across at our site. This is in the Finger Lakes at our Penn Yan site. Beautiful image of sastrugi. This happens often in the Arctic. So current state of affairs, anyone who's been on a lake or pond or river up in the North Country at least knows many of the rivers are at base flow. We're in a D1 drought, which is that upper right image. However, again, this is the tale of two states in the Southern Tier and Hudson Valley, and especially over the last 2 or 3 days. The lower Hudson Valley in New York City, I've got bombarded with rain. So locally, 16 of the last 17 days, we've recorded measurable precipitation here in the North Country. So I think we are in the rebound, but we are certainly very dry up here. This is an accumulated precipitation graph from one of our wetter sites. This is each of the last year's precipitation accumulating, with the magenta being the current year. This is one of our wetter sites, and I show you this to compare to. This is our Wesley Island site up along the St. Lawrence River. Very significant drought, D1 drought up there. You can see how the magenta line, we are lagging far behind compared to other years at this time. So a quick look ahead, and then I'll wrap up. For those who haven't followed the weather kind of locally, and this will go into a brief synopsis of weeks ahead anyway, our summer weather in the Northeast is largely dictated by the strength and position of the Bermuda High. Lately, it's been strengthening, so we do have pretty humid air with the occasional piece of energy or shortwave tracking across the Great Lakes, which will add kind of a cold shot or convection. Then we get a re-energized pulse of humid hot air from the Bermuda High off the Gulf of Mexico. The Sonoran heat ridge is also amping up, which has upstream effects for our weather out west. And we've all heard about the heat that they're dealing with out there. Long-term forecasting is all about indices. We're entering a moderate La Nina episode. That usually strengthens the Bermuda High or the Great Smokies heat ridge, which for us results in continued kind of hot and humid weather, which is a pretty easy bet for a weatherman to forecast in the summer, but at least it has some scientific underpinnings here. With the Bermuda High being so strong, it does curve any kind of tropical development, hurricanes, tropical storms along the eastern seaboard and up the East Coast, which is another concern. So I will end it there. I knew I threw a lot at you and spoke pretty quickly. This is our Philadelphia site. That is that cold spot, a quick drone video of what one of our sites looks like. And I'm happy to open up to questions if there are any.
Scott, wonderful. Thank you very much. That was a great overview of the Mesonet, and I was really hoping you were going to end actually with the drone. I remembered that actually.
Great. Yeah.
We actually have our first question in the chat. Craig, would you like to read it, or are you okay with us going ahead with it? Okay, so can you comment on the state of the working relationship, if any, between the New York State Mesonet, New York State DOT, and the Department of Environmental Conservation, as well as NOAA, National Weather Service, LFOs?
Sure. Yeah. I am not involved with the Mesonet at a level to probably speak to formal working arrangements with them, but we do have a network along the Thruway, which works closely with the DOT for them monitoring all sorts of weather phenomena with a focus on road weather specifically. And I do know the Weather Service ingests all of our data, and we are in contact with them often. They use our camera images and all of our weather data quite often. So we do have this data, and I think it's in our best interest and the scientific community in whatever kind of slice of the weather pie that they're dealing with to leverage this data as much as possible. So I think it's in our interest, and we try to share that data as much as possible and have a working relationship so people can access that data. Yeah.
Great, thanks, Scott. The floor is open. If anyone would like to either enter a question or comment in the chat, or also use the Zoom raise your hand feature, please go ahead. Yep, we do have one raised hand, and that's Richard. I will ask Richard to unmute.
That was excellent, Scott. A remarkable talk. A couple of questions. One thing that just fascinates me, just from a homeowner standpoint, it seems like when you try to dig a hole in the winter, the ground is frozen. But it's really clear you guys have made a huge effort to show that the ground temperatures are very close to the freezing point. So I'm curious if you have a comment on that. And then I have one other thought, is that as Chris Thorncroft said at the beginning, Ray Falconer got this whole endeavor rolling for us at Whiteface, and it would be wonderful if you could give like a weekly weather update in kind of like what Ray used to do, because we would all learn a lot. It's always a privilege to hear you talk about the weather. Yeah, thanks.
Thanks, Rich. Thank you. Kind words. Yeah, on the second point, I would love to make that happen. On the former point, I know we have an expert on the talk here who is a soil scientist. I can't speak too much on it. I haven't studied the soil too much. Craig, I don't mean to put you on the spot. Is there anything you want to add, or?
Well, I think that the Mesonet has looked at this issue quite in depth, and they're confident in the measurements, and there's nothing that suggests that the data is not trustworthy. I think kind of the rule of thumb, and most engineers know kind of the depth that you lay a water distribution system is based on the depth of freezing, and that they put the hydrants down 4 or 5 feet into the ground, 3 to 5 feet. So that the hydrants don't freeze up hardly ever, and those are always cleared out, so they never have a snowpack on top. So that gives you a sense that the ground isn't really freezing that as deep as some people think that it is.
Yeah, thank you for that, Craig. Thank you.
Great, excellent comments and questions. Scott, actually, I have one. You showed us some examples of some of the neat things you've seen, you and your technicians that work for you, with the mice and the biting bees and all those sorts of things. From your experiences, what's the strangest thing you've seen when you've been out doing site management, site maintenance? And
Oh,
I'm
geez.
sure there's many, but can you point to one that is exceptionally unique?
Ooh, some of the human encounters, as strange as the wildlife and as awesome as experiencing a lot of this weather, maybe some of the human encounters. With some of the greatest part of the job, we're kind of interfacing with a lot of these site hosts, especially our sites that are on private land. This image you're seeing here is our Philadelphia site, which is a winery, and you can often get sidetracked talking to site hosts, and they often know way more about the weather, local weather, than you could ever learn in kind of a college course or by reading books. And that's the kind of knowledge that I really crave. They know where convection lines approach from the west and where they split, and they have different kind of metrics or proxies for forecasting just based on kind of empirical. If the day dawns this way, it's going to be this way, and you can't hay that day. And yeah, I guess a lot of times we find nesting birds at sites and they surprise you. We've found some pretty interesting things in our rain gauges, from birds to insects. I guess one anecdote, we had a false accumulation at one of our sites and we could not figure out what was happening. Clear days and our rain gauge would be indicating that it would be raining. We sent technicians to the site, couldn't find anything going on. We sent another technician at kind of a follow-up visit, same person, in fact, and it turns out slugs were getting very lightweight slugs, but they were climbing the pedestal and up around and getting into the rain gauge, and just their weight is enough to kind of trigger this very sensitive load cell. Yeah, I guess
That won't be the last of the stories, I'm sure.
No, yes, correct.
We do have another question. I believe it's another follow-up from Craig. Are there plans to expand the network, either in terms of the number of sites or number of instruments? On that note, any softening of the tall tower restrictions in the Adirondack Park?
Yeah, so we're always looking to be better. I think we often we want to curb our growth when quality might go down. So we're very careful about not growing too fast and making sure we can handle what we currently have. As far as adding sensors, I know there's some side projects where some of our sensors, we have some studies with maple researchers who are temperature underneath a canopy compared to a field. So we have a lot of pretty unique projects going on. But as far as network wide, I'm not aware of any sensor additions, although we're very open to that. I think maybe more network wise, we have snow flux profiler subnetworks and then utility networks in the Hudson Valley and New York City. There has been a push for a hydrology network. Kind of, we have the drivers of a lot of flooding being mainly rain inputs, snow, how much water is sitting in the snowpack from our snow network, and then soil moisture. But with a lot of the flooding being the direct result of high watershed blind spots, we would like to expand into the realm of some stream gauging stations, but that has not been explored too much. We're also interested in mountain meteorology, perhaps a summits network, the southern tier, Lake George, Prospect Mountain, Whiteface here, the Tug Hill, Slide Mountain in the Catskills. I think there's an opportunity to learn more about mountain meteorology here in the States. So we are always looking to expand. But a lot of those decisions, I think, are probably money driven and maybe a little politically driven. So,
and maybe you already hit on this part, but any softening of the tall tower restrictions? Did you already cover that?
No, not that I'm aware of. Yeah, I believe that's an APA guideline. Yeah, so not that I'm aware of, Craig. Yep, sorry, I forgot about that.
Okay, no worries. Okay, anyone else? Any comments, questions?
I'll just add, want to definitely thank all my my coworkers. This was a kind of a group effort putting this together, and we're the ones out there kind of interfacing with the weather and the weather stations, but we have a whole team of people who make this all happen behind the scenes. And it's a great kind of cohesive, small but mighty group. And we got a lot of support from the university too. So nice group effort. So thank you to everyone.
Excellent. Thanks, Scott.
Thank you, Scott. Great talk.
Yeah.
Well, if there's no questions, I'll give people a couple of minutes to think about it. In the meantime, I just wanted to remind you of a couple of things. For those of you who might have come on board a couple of minutes late, if you look in your chat feature in Zoom, Dr. Ferguson put in a link to a Google survey. We would really appreciate your feedback. We're looking for ways to potentially improve our Falconer lectures, both the spring and summer series. So please, please visit that link and give us some of your ideas and feedback. Our next summer Falconer talk is July 27th, Birds and Climate in New York's High Elevation Boreal Forests by Dr. Jeremy Kirschman, who's the curator and ornithologist at the New York State Museum in Albany, New York. So we hope you will join us for that as well. If there are no further questions or comments, I think we will bring the night to a close and let everyone enjoy the nice summer evening. Oh, we have a clapping hand, so the hands are coming in. Great job.
Thank you, everyone.
Really
Thank you.
appreciate the talk.
Yeah.
Thank you, Scott.
Excellent. So we wish everyone a pleasant evening, and we'll hope to see you on July 27th.